Hi, I'm Andres, and this is my final project presentation for AWS Cloud Platforms. We are working with a steel 4-inch line producer track change linked for heavy machinery. Each piece goes through full production cycles, the furnace, multiple press strikes, and finally a quench bed. And then the whole process takes around 58 seconds. The problem here is the time that the piece reaches the bed is already too late to fix actually something in the process. So what we did is to create a predictive model to actually detect um, if there's something wrong in the early stages of the process, and so we can actually the operator can actually do something. This is between the first 18 seconds into the process. And let me talk about the architecture of the AWS. What we did is to create a Streamlit app on a ECS Fargate that is a serverless container service. When a user selects a piece, the app actually sends a request to the SageMaker real-time endpoint where our machine learning model runs and is stored in the S3 bucket and is a XGBoost model. And also all the logs are captured in the cloud watch. So everything that if there any problem, you can actually see where's the problem and detect it within the process. And now I will show you the actual application. Uh, here. Here's the application, and it's running on the EU West 1 region, Ireland. On the left side, we can see they interact with the Streamlit app running on the Forget. The key idea of the Fargate is that we don't manage infrastructure. We just define the container resource and the AWS handle the rest. Here's where the four different models used in production. Each one has a slightly different timing behavior. So actually it's important for the model to select one. For instance, let's select the 5052. And now we can see all the pieces from this exact model. And we can select any piece that we like, for example, this one. Um, then clicking on the piece, we can actually see all the full journey of this piece through the whole line, from the furnace through the 5 press stages, all the way to the quench bed. This level of visibility is key. Instead of just seeing the total cycle timing, the operator can actually understand exactly where the delays are happening, and also you can see like in a graph, so it's more visual. And now to the bottom of the app, we see the inference panel. The app takes the key features matrix, time after the second strikes, and the OEE, and sends them to the SageMaker endpoint that we saw in the architecture. The response takes about 50 milliseconds, in this case 70, but it's around that number. Um, in the real-time decision making, it's quite good time actually. And in this case, the model prediction VOD time is around 56, 57 seconds, which is within the accepted ranges. Um, and also, of course, we can do this within other kind of pieces and select whatever we want, see how it goes, in which stages it could be some problems, and if it's over the threshold to detect that it's a problem, um, we can actually see here. Just to wrap it up, this project is not just about deploying a model, it's about bringing a real-time intelligence into an industrial process where the timing and the precision directly impact on the cost effect. We built a fully end-to-end pipeline from the data precision to the fully deployed AWS. I hope you like it and you enjoy it. Thank you for watching.